Okay, Karoo, here's a short little video about the Truncus. Okay, so the Truncus is very similar to our hyperbola that we saw in 4a, so this is actually for 4b. Right, our rule is y equals 1 on x squared. So our hyperbola was 1 on x, we're now 1 on x squared. Okay, and this is the shape that we get. Okay, so it's called a Truncus because the graph looks like a tree trunk, if you like. Okay, so what we say about this function, okay, is if we put in these values of x into the function, we get these values of y. So we can see if we put in -3 in here, we're going to get positive 1 on 9. -2 is going to give us positive 1 on 4. -1 is going to give us positive 1. 0 is undefined, I'll get to that. 1 gives us 1, 2 gives us 1 on 4, and 3 gives us 1 on 9. So we can see this shape being mirrored either side. Okay, now while we're undefined here, right, is we can't have, just like our hyperbola, we can't have a 0 in our denominator. Okay, we can't divide something by 0, so we end up with this vertical asymptote at x equals 0. So again, just like our hyperbola, and again, just like our hyperbola, we also have a horizontal asymptote at y equals 0 coming through here. Okay, so the difference is where our hyperbola came down here, okay, and came down here, our Truncus comes here and here. Okay, interestingly though, because we're squaring our values, okay, our Truncus actually comes in a bit tighter. So if we were to draw a hyperbola on here as well, it would be more, sorry, it would still come through the point 1, 1, which would be, say, here. Okay, but we're going to be a bit tighter when we come down. Okay, so we're going to come through here. Sorry, no, we're not. The Truncus is going to be tighter. Sorry. So our values aren't going to get as small as quickly, right, or as large as quickly. So we're going to be like this for our hyperbola. Okay, so because we're this squaring factor, okay, means that we're going to get smaller and closer to our asymptote a bit quicker. Right, so got a bit more that we need to talk about. Okay, so as I probably have told you about our hyperbola, we've got our interesting point form. Okay, and it's going to be basically exactly the same as for our hyperbola. Okay, so we've got this time a on x take h squared plus k. So the point hk, so I'm going to change the sign in this bracket, okay, tells you where the asymptotes cross. So this is our interesting point, but not actually on our graph. Okay, so that's important. And a is a dilation factor that stretches or compresses our function. So if we've got y equals just 1 on x squared, that's our black line here, and that's when a is equal to 1. If we have y equals a on x squared, that's our red line here, and this is what happens when a is bigger than 1. Okay, our blue line here, okay, is y equals 1 on ax squared, and really this is when a is less than 1. But I should say that's between 0 and 1. Okay, I'm not talking about negatives there. Okay, and really, so that's a fraction. Okay, so if we had y equaled 1 on 3x squared, okay, then our a value, that's 1 on 3. Okay, that's what's going on here. Okay, so that's what we're saying is happening with this blue one. Right, then I've just got an example of a question to do, which is sketch y equals -2 on x take 1 squared plus 1. Okay, the first thing is always going to be to draw our axes. Okay, and you start going through what you know. Okay, so we know here, okay, that the graph has been moved to the right by 1, or so we change our sign there. Remember, always change our sign here. So we move to the right by 1. We're moving up by 1. Okay, so that means our interesting point now is at 1, 1. Okay, so this is where our asymptotes are going to be. We're going to go through 1 and this way down through 1 as well. Okay, now we just need to see, well, what's going on with that -2. Ooh, so we've got a negative this time, so we also go, well, what's the negative going to do to our graph? And it is going to change it a little bit. Okay, and the 2 is also going to stretch it. Okay, so what we're saying now is that we've got a reflection here, and this reflection, because it's closer to the y than the x, it's at that reflection down. Okay, so we've got our answers, if you like, by subbing in values for x into our equation. We've still got this y value, and then we're going to times it by -2. So let's go flip it down. So our graph is going to actually go like this. Something like that. Okay, now we actually need to do some work though and find out what we might get here. So if we try to find these x-intercepts that should exist, we let y equal 0. So we say 0, because remember that's always what we do. Our y value here and here is 0. So we let it equal to 0, so we've got that's equal to -2 on x take 1 squared plus 1. Okay, so what we're going to do is we're going to take 1 away. Let's say that's equal to -2 on x take 1 squared. Now we're going to do a little cheaty thing here, so we're going to multiply across, okay, and then we're going to, so actually I won't do too many steps at once. 1 squared equals -2. We're going to cancel out our negatives, okay, take the square root, so we've got x take 1 equals the square root of 2, and that will be plus or minus the square root of 2, and then x is going to equal plus or minus the square root of 2 plus 1. Okay, so that means that we're going to have two values, x equals -√2 plus 1, right, and x equals √2 plus 1. Okay, -√2 is about -1.4. Okay, so I've actually drawn this a little bit wrong, okay, because I said both of our x-axis intercepts were positive, and that's not true. Go down. Whoop. I've exaggerated that a lot, but anyway. I'll fix it up. Okay, so this one is our -√2 plus 1, and this one is +√2 plus 1. Okay, so there are x-intercepts as well, and we're done. We've actually got everything we need. Okay, because we're showing these other points, okay, then we've shown that dilation factor in there as well, that 2. Okay, so it's very similar to our hyperbolas. Okay, and we'll look at truncuses and hyperbolas a lot more again next year. Okay, but hopefully that's enough to get you through the few questions that there are in section 4B.